This question here is a little bit different just in the way the data is presented. When you click the icon to view the table of scores, they give you one set of scores. Here they give you all the scores, and over here they just give you a summary. And if you go into the calculator and look here, when you do what's required here, two-sample t-test, you can either use a list of data or you can enter the raw stats, right? But you can't do a mix of both. So the only way to make this thing work is to go find these numbers into X bar 2 S2, do it for the left hand side and call that S1. So you hit stat and type in those values, which I already have, and then you'll hit stat again. You can calc one bar stats for that, and there you'll get the numbers you need. You get that there's 11 items, N is 11, X bar is 91, and SX is standard deviation, which is 10.421. So what we'll do here is we'll go and do this test now with just these sets of data, two-sample t-test. And so we're going to change it to stats there, and then go down and enter your values here. Alright, and so now that I've typed the values in, we need to decide here what is the alternative hypothesis. And so the null is always that they're equal. And so we're going to test the claim that the mean IQ scores for subject with medium lead levels is higher than the mean with high lead levels. So we're going to try to prove that mu1 is greater than mu2. We need to talk about that because that's important over here on the calculator. So mu1 is greater than mu2. So we're going to change to that. And we also have to write here that this is pooled, that the answer is no. And the reason it's no is because it says do not assume that the population standard deviations are equal. So if we don't assume they're equal, then we do not pool the standard deviations. Alright, so that's what happens there. And so we'll leave that as not pooled, and we'll go down and calculate. And here's where we get our t statistic. So again, we have put in our t, this is rounded to 2 decimal places, that's 0.31, and the p-value here is p is 0.380 for 3 decimal places. And so the conclusion is we fail to reject the null hypothesis because the p-value of 0.38 is not less than the 0.05 significance level. So remember, it's fail to reject, and there is not sufficient evidence. Those two go hand in hand. The other fail to reject does not make sense. And then the next part says construct a confidence interval suitable for testing the claim. So again, what we want to check here is the difference in the means. If it has 0 in that interval, that means that it is possible that there is no difference. That's what we test for right there. So if 0 is in between the endpoints here, that means there's possible that the difference in the mean of 1 minus the mean of 2 could be nothing. There could be no difference. Alright, so when we set this up, recall I said this in a different video, but you may not have seen it. So for that one, what we have to say here is that if the confidence or the significance level is 0.05 on a one-tailed test, we're talking about 0.05 here, or 5% is in this tail. So when we want to do a confidence interval, even though this originally was a one-tailed test because we were testing whether mu1 was greater than mu2, for the confidence interval we assume that it's two-tailed, and we put 5% over here as well to do the confidence interval. And I'll show you how that factors into the calculator. So for the calculator, I'm going to clear out that one. Now I'm going to do stat tests, and I'm going to go up from the bottom because it's a two-sample t-interval. It's the 10th one down on the list. And so it keeps your data from last time. And so the only thing we need to change is that confidence level. Now it's going to be 0.9. Alright, the reason again that it's 0.9 is because if we have 5% on either end, that means we have a 90% interval here in the middle. So that's why that becomes a 0.9. Alright, so we'll do 0.9, and then we'll hit enter. And again, pooled is no. And we calculate, and we get our interval is going to be negative 6.242 to 8.972. Alright, so that's what goes in the next answer block. So to round this question on out, we type in those numbers, and then, as I said earlier, this confidence interval supports the conclusion that we fail to reject because the confidence interval contains 0. So it is quite possible that the difference in IQs between these two is actually 0.